अस्सलाम वालेकुम गाइस। आज हम पढ़ेंगे फिज़िकल प्रॉपर्टीज़, एटॉमिक एंड फिज़िकल प्रॉपर्टीज़ ऑफ अल्कलाइन अर्थ मेटल और ग्रुप 2 एलिमेंट. They are called alkaline earth metal because their hydroxide are alkaline in nature, and their ore, and they extracted from the ore which are present in the earth crust. That is why they are called alkaline earth metal. First, we discuss atomic and physical properties. Among atomic and physical properties, first we discussing the trends in atomic radius and the atomic size. We discussed in the previous lecture what is atomic radius, the distance between the nucleus and the outermost electron. As we go down the group, in case of alkaline earth metal, as we going from beryllium to barium, the size of the atom increases, as you see here. This is beryllium, magnesium, calcium, strontium, and barium. The alkaline earth metal consists of these elements, starting from beryllium to radium. Radium is radioactive elements. Now, as we moving down the group, the size of these atoms increases as we see from this diagram. Now the question is why the size is increases, why the radius of alkaline earth metal increases as we moving down the group. The simple answer is that as we going down the group, extra shell are added and the atomic volume increases from beryllium to radium. It means that as we moving down the group, new shell are added in each period. For example, the electronic configuration of beryllium is 1s2 and 2s2. Second shell is its outermost shell, while the electronic configuration of magnesium is 1s2, 2s2, 2p6, 3s2. So, third is the outermost shell of magnesium. Now, here one shell is extra than this one. Similar one shell is extra added here. As we going down the group, extra shell added, which result in increase in atomic size. When extra shell is added, it means that it will reduce the nuclear attractive forces due to increasing shielding effect. When extra shell is added, it means that more number of inner electron. When more number of inner electron, then the shielding effect, the reduction in the nuclear attractive force will be increases. It will be decreases. So the electron will experience less attractive force from the nucleus, the result of which the size of atom increases. Now, the atomic radii of these elements means the atomic radii of alkaline earth metal are smaller than those of alkali metal in the same period. For example, sodium is here in the periodic table. Sodium is here. Sodium and magnesium are in the same period. The size of sodium is larger than magnesium. Similar, the size of lithium, which is present here, is greater than beryllium. Now, this is the second question, that the atomic radii of these elements are smaller than those of alkali metal in the same period. Why? The simple reason is that this is due to the fact that alkaline earth metal have higher nuclear charge. As we moving across the period, in periodic table, nuclear charge increases. For example, Sodium have 11 proton, its atomic number is 11, so its nucleus has 11 positive charge. While the atomic number of magnesium is 12, so its nucleus has plus 12 charge. So the nuclear charge increases while the outer shell remain the same. So increasing nuclear charge will increase the attractive force between the nucleus and outer electron. It will result in the decrease in atomic size. So we say in the same period the size of alkaline earth metal will be smaller than the size of the radius of alkali metal. When the nuclear charge increases, it tends to draw the orbital electron towards the nucleus with more power as compared to the alkali metal. So this is the sample. There are two questions. One, why the size of atomic radius of alkaline earth metal increases down the group? The answer is this one. The second question is why the atomic radius of alkaline earth metal is smaller than the alkali metal. Then the answer is this reason. This is. Now, what is the consequences? What is the results of the smaller radii, the smaller radius of alkaline earth metal than alkali? The smaller value of atomic radii of alkaline earth metal results that alkaline metal are harder than alkali metal. They have higher density than alkali metal. They have higher melting and boiling point than alkali metal. Now, if somebody say that why alkaline earth metal are harder than alkali? This is due to smaller value of atomic radii. Why radii are smaller? The reason are above. Why alkaline earth metal are more denser than alkali metal? The simple answer is small atomic radii. Why alkaline earth metal have higher melting and boiling point? The answer is again small atomic radii. And why the atomic radii is smaller? This is the answer. This reason is the answer that why atomic radii of alkaline earth metal is smaller than alkali metal. Okay. Now, trends in ionization energy, trends in electronegativity, and trends in melting and boiling point of alkaline earth metal. So, ionization energy, as we already discussed in the previous lectures, that it is the amount of energy required to remove the outermost electron from an isolated atom in gaseous state. The ionization energy is decreases as we moving down the group. Same pattern is observed in the alkali metal case. The first A group also show the same pattern. It means that as we going from beryllium to barium, the ionization energy decreases. Now, why the ionization energy is decreases? The reason is that increasing atomic radii. As we going down the group, the atomic radius of second A group increases. When atomic radius increases, the ionization energy will be decreases. It means that atomic radius is inversely related to the ionization energy. Why? Because the nuclear attractive force on the outer electron of smaller atom will be more as compared to the nuclear attractive force and the outer electron of larger atom. When the attractive force between nucleus and outer electron is strong, then more energy will be required to remove such type of electron, and automatically the ionization energy increases. When the nuclear attractive force on outer electron is less, then it will be easy to remove such type of electron and less amount of energy will be required, so the ionization energy decreases. So as we see that beryllium is moving from beryllium to barium, the size increases. When size increases, it means the removal of electron become easy. The removal of electron require less energy, so the ionization energy decreases. In case of beryllium, 900 kilojoule per mole energy is required to remove its outer electron, while in case of barium only 500 kilojoule energy required for removing its outer electron. Now the question is that how they are decreases down the group. One is atomic radius, but besides atomic radius there are also two other factor. One is nuclear charge and other is shielding effect. These two factor, this is already discussed. Now these two factor, as we going down the group nuclear charge increases, as we down the group shielding effect increases. Nuclear charge increases, shielding effect also increases. And shielding effect, nuclear charge are inversely related. Shielding effect when increases, it decreases the nuclear charge. So as we going down the group in periodic table, this factor will increase the ionization energy, while these two factors decrease the ionization energy. The effect of this factor is counterbalanced by the shielding effect, so the net effect is produced by the radius. That is why we write here that the ionization energy decreases because of increasing atomic size. Similar is the pattern for electronegativity, because electronegativity is the capacity of an atom to attract a shared electron towards itself, and usually atom shared its outer electron. When the attractive force of nucleus on outer electron is stronger, then it will attract the shared electron with more power. When the attractive force of nucleus on the outer electron is less, then the attraction of the shared electron will also be less. And we know that as we going down the group, the attraction of nucleus on outer electron decreases, so the electronegativity also decreases as we moving from beryllium to barium. Now transient melting point. The melting and boiling point of second element, second A group, yani alkaline earth metal, is higher than first element, so higher than alkali metal. Melting point generally depends on the strength of metallic bond. Now the question is, why the melting and boiling point of alkaline earth metal is greater than alkali metal? So there are two reasons. One reason, as we already discussed, is its small atomic radius, and the other reason is that the strength of metallic bond of alkaline earth metal is stronger than alkali metal, because alkali metal have only one valence free electron which take part in metallic bond, while alkaline earth metal have two valence electron which take part in the formation of metallic bond. Now the question that why the melting and boiling point of group 2A is higher than group 1 element. So there are two reasons. The first reason is the atomic radii of second A group is smaller than first A group. The second reason is that the metallic bond of second A is stronger than the metallic bond of alkali metal. But the trend of melting in boiling point of alkaline earth metal is not regular. It is not regular trend like this. This is a regular trend. Down the group decreases. But there is no any regular trend. This high melting point, this is lower, and this again high, this is lower, this is again high. And there is no regular trend in the melting and boiling point of the alkaline earth metal is observed.